We're back with more nomenclature fun. And so this is Skills from First Year Chemistry 101, and this is the nomenclature of acids, and my colleague calls this kicking acids, just for fun. And this is the third part of the series of nomenclature notes. So what we want to remember with acids, and this is a really general definition for acids, there's a whole field of chemistry that's related to defining acids and bases. And so I'm just going to simplify for today that an acid is any substance that leads its formula with a hydrogen ion. So anything that starts with hydrogen, we are going to consider and name as an acid. And something that you want to remember is that in acids, we have hydrogens. They are attached to anions. And the number of hydrogens depends on the charge of the anion. So for instance, if I was looking at something like the anion of, we'll do carbonate. The anion carbonate, and I was asked for what's the acid formula that the anion carbonate would form, since this is a -2 charge, then I would just add 2 hydrogens to the formula, and I would put it at the beginning. So it would be H2CO3 with no charge, because the hydrogen balances it out. Okay, as another example, we could do just regular old chloride, Cl-1, and so the acid version of chloride is HCl, one hydrogen only, because the charge here is -1. And we'll do one last little example on that. We have PO4 -3 phosphate. Then the acid that it would form is H3PO4. So you just add the number of hydrogens to balance the negative charge on the anion. So that's one thing that you want to remember about formula writing of acids. And so nomenclature, or naming of acids, the overarching principle or guiding principle for naming of acids is that acids get their name from their anions. So acids are named for their anions. So kind of like we get our last name from our parents, acids get their names from the anion that makes up the acid. And if you've ever conjugated a verb in a different language, like in Spanish, you will very easily understand what has to happen in order for us to name an acid from its anion's name. And even if you haven't conjugated a verb in another language, you can still learn it. It's easy. And so you kind of have to be a little bit of a decoder. Or I don't know, like a word smith.
Dun, dun, dun.
Yeah, exactly. Okay, so we want to remember that acids are named for their anions, and there's 3 different endings for anions. So 3 endings for anions. And those are ending in IDE, ending in ITE, and ending in ate. So they can end in ide, ite, or ate. And so depending on the name of the anion, what it ends in is going to determine how you approach naming the acid. Okay, so let's say for example, we're going to look at the ide first. So if we have the anion here, and then the acid formula, and the name. Let's say that we're looking at the anion fluoride, F-1. And we know that since this is a -1, then our formula for the acid is just going to be HF. And with anything that ends in ide, what you're going to do is take the name of the anion, which is fluoride, and you're going to drop the ide, and you're going to add hydro to the front and ic to the end. So you drop the ide and add hydro and ic. So if we did, for example, chloride, and the acid formula would be HCl. And so what we would do is look at the name of the anion, which is chloride. We would drop the ide and add hydro, and then enter the middle part of the word, the base part of the word, and ic, and then acid. And I forgot to write that up there. So we have hydrochloric acid. Okay, so that ends in, oh, am I too far? Sorry. So that's if the anion ends in IDE. So these are examples of IDE. So we're going to go on to ite and ate right now. Okay, so we just did ide, and let's say we have the anion. Let's do sulfite, SO3 -2. So this is sulfite. And you know what? I'm not going to use that as an example to start out with because it's an exception. So we're going to come back to this one. Let's put a star next to it. Hang on. We're going to do the anion chlorite, and that is ClO2 -1. So, like I said, let's put a star next to this guy. He's an exception to the rules, so we got to come back to him. Okay, so if we have the substance chlorite, its acid would be HClO2, and with this, the rule is you drop the ite and add us, so it would just be chlorous acid. Chlorous. So you drop the ite and add us. And I'm still off the page there. Okay, so chlorite would turn into chlorous acid. Let's say that we're looking at ClO -1, which is hypochlorite. And so its acid formula would be HClO. And we would just look at, oops, yeah. I think I've been videoing for too long here. Hypochlorite, we're going to drop the ite and add us. So it would be hypochlorous acid. Okay, so that's the ite. And so ide becomes hydro and ic, ite becomes us, And then let's say that we have a substance that ends in 8, like nitrate, for example. And our acid formula is HNO3. And with 8s, again, you're going to drop the ending, which is 8, drop the 8, and you're going to add ic acid. So this becomes nitric acid. Okay, and I always remember this as if I ate too much, then I feel icky, right? That's just the little trick of the trade to remember. Okay, so ide becomes hydro-ic, ite becomes us, 8 becomes ic acid. Okay, and then there are 2 exceptions that you need to know about, and the sulfide is one of them. 2 exceptions. And those are the sulfur oxyanions and the phosphorus oxyanions. So let's say we have sulfate or sulfite, phosphate,